This brain-twisting equation looks easy until you try solving it. We have given n factorial equals n cubed minus n, and our goal is to solve for n. Take a moment to think about it. Pause the video if you want to try solving it on your own, and then come back to check your answer. Alright, let's solve. But before we start, let's quickly recap. For those who don't know what factorial means, when you see something like n exclamation, it means you multiply all the natural numbers from n down to 1. For example, 5 factorial means 5 times, 4 times, 3 times, 2 times 1, which equals 120. 4 factorial means 4 times, 3 times, 2 times 1, which equals 24. Now, did you notice something? This 5 factorial can also be rewrite as 5 times 4 factorial. And similarly, this 4 factorial can be written as 4 times 3 factorial. So in general, n factorial can be rewritten as n times n minus 1 factorial. Now let's go back to our equation. N times n minus 1 factorial equals n cubed minus n. Now rewriting n cubed as n times n squared, and taking n common, the right-hand side becomes n times n squared minus 1. Now canceling n from both sides, we are left with n minus 1 factorial equals n squared minus 1. Now this is where the real fun begins. Let's expand n minus 1 factorial as n minus 1 times n minus 2 factorial. On the right-hand side, we have n squared minus 1, which can be rewritten as n minus 1 times n plus 1. So now we have n minus 1 times n minus 2 factorial equals n minus 1 times n plus 1. Again, canceling n minus 1 from both sides, we are left with n minus 2 factorial equals n plus 1. Let this n minus 2 be k. So n equals k plus 2, and n plus 1 becomes k plus 3. Thus our equation becomes k factorial equals k plus 3. Since the left-hand side is a factorial, it must be an integer. That means k must also be a whole number. Subtracting k from both sides, we get k factorial minus k equals 3. Now rewriting k factorial as k times k minus 1 factorial, and substituting into the equation we have k times k minus 1 factorial minus k equals 3. Taking k common from both terms, k times k minus 1 factorial minus 1 equals 3. Now let's try small integer values for k. If k equals 1, then the equation becomes 1 times 0 factorial minus 1 equals 1 times 0, which is 0, not equal to 3. Now let's try k equals 3. 3 times 2 factorial minus 1, which is 3 times 2 minus 1, or 3 times 1, which equals 3, which is equal to right-hand side. So k equals 3, and since n equals k plus 2, we find n equals 5. Now let's verify our answer. On left-hand side we have 5 factorial, which is 120, and on right-hand side we have 125 minus 5, which is also 120. And that checks out perfectly. So the final and only solution for our equation is n equals 5. But wait, before you go, I have one more challenge for you. Can you find another value of n that satisfies this factorial expression? Think it through and drop your answer in the comments below. If you enjoyed this explanation and learned something new, don't forget to hit that like button, share it with your friends, and make sure to subscribe for more brain-teasing math questions. Thanks for watching, and I'll see you in the next video.